So the question gives us a beam which is 1.25 meters long. It's supported in two places, A and B, and they're separated by 1 meter. We've got a 0.25 meter overhang here, and a load going down is applied at the end. Then we've got two reaction forces, RB, so the support is pushing up on the beam, and we're told that's 26 newtons. We don't know what the support force RA is here at this point, but we've got a UDL, a uniformly distributed load of 40 newtons per meter acting over 1 meter. We have to find, or the first thing we have to find, is the maximum load L that can be applied, in other words, without tipping the beam up. So the first thing we need to do is a little bit of side working, and what we do is we take the UDL, 40 newtons per meter, and multiply that by the length over which the UDL is applied. In this case it's just 1. So that tells us that the UDL can be thought of as a single force of 40 newtons, and that is going to act halfway along the distance the UDL is acting. So as the distance here is 1 meter, we can think of that UDL, we can replace that with a single force of 40 newtons acting at 0.5 meters from point A. Okay, so now what we do is we apply the principle of moments. So you want to choose your pivot point to be in an area where you've got a force which you don't know that you want to get rid of in your calculations. So we don't know what RA is, we need to find L. So for that reason we choose the force we don't want to find, and that's where the pivot is going to be. Okay, so what we do is we take the clockwise moments, clockwise is our positive direction about the pivot point A, and then we work from left to right. It's going to be a little bit difficult to get all of this on screen, but I'll do my best. So first force we come to is the 40 newtons we just worked out, and that is a distance of 0.5 meters away. And because this is pushing down to the right of point A, that's going to have a clockwise turning effect. Okay, so that first bracket stays clockwise and therefore is positive, so it remains positive. The second force we come to is a 26 Newton force pushing up at a distance of 1 meter. So that's going to be an anti-clockwise moment. So for that reason, the 26 times 1, we put a negative in front of that. And then the final force is L times 1.25, and we put a plus there. Okay, and all of that lot must equal 0. So then if we multiply out the brackets, we get 40 times 0.5 is 20, 26 times 1 with the negative in front is negative 26, and then we've got plus 1.25 L is all equal to 0, and then we work through the equation in the usual way, and that gives us a final answer of L equal to 4.8 newtons.